Hi again. We're going to continue on with going over the quiz. We're going to do pages 2 and 3 right now. So let's pick it up from there. So number 6 is all about the jelly beans and figuring out all sorts of measurements from that set of data. And it all should fit together. First one is average. That's pretty straightforward. You add them all up, divide by 1, 2, 3, 4, 5, 6, 7 different jelly beans, and we get 3.83. So I'm not going to show the work on that. That's pretty standard. You really should put the units on there. If you didn't, I didn't really worry about it. Okay, now the new stuff. Random error. Random error is maximum value minus minimum value. So our maximum value, I think, is 4.22. Our minimum is 3.46. Divide that by 2, and we should get 0.38. If you round that to 0.4, that's fine. I accept it either. And again, it should be grams. All right, what's the percent uncertainty? So this random error, this is our delta, really, mass. And this is our mass, okay? Our percent uncertainty is simply delta m over m times 100%. Okay, I don't care if you called it a percent or if you left it as a decimal. So you can put 0.38 over 3.83, and that comes out to be 0.099, which is equal to essentially 10%. All right, your numbers might be slightly different than mine. I'm wondering if I chose the wrong value for my whatever. So anything around there is okay. Okay, now density, right, is equal to mass divided by volume, and the percent uncertainty is 6%. So what is the percent uncertainty in density? So the idea is, I'll call density D, is mass divided by volume. Actually, yeah, I'll just leave it like that. So my percent uncertainty in this is the sum of the percent uncertainties in that. So percent uncertainty in D is percent uncertainty in volume plus the percent uncertainty in mass. And you were given percentages. So if percent on volume is 6%, and this we found to be 10%, add them up, and we get 16%. Now, for C, we're asking for the absolute uncertainty, knowing the percent uncertainty and the value of the density rho. So I guess I should have called this rho. Sorry. So two things you want to do here. So the calculation for that is I'm going to say delta rho is equal to my value of rho that we found above multiplied by that percent uncertainty in rho. Okay, so our density we calculated. Did we calculate it somewhere? Oh, I'm sorry, it's given. Okay, so it's going to be equal to 1.2345 times 16%, or 0.16. And when I multiply that out, I get about 0.20. Okay, and there are units with this. It's a density, so it's grams per cubic centimeter. So now I want you to take, for this next part right here, I want you to take your results for delta rho, right, that's what you just found. Take the rho, the density which was given, and put it together where you're considering rounding. So this is the approach. I allow you to keep this to the nearest hundredth. So if you got your uncertainty to be 0.20, what that means is you need to round the density to the nearest hundredth. In other words, we ignore that. So what I'd say is rho is 1.23 plus or minus the 0.20, and then don't forget your units. A number of you did forget your units. A lot of you did not round this properly. I would also accept, and which is technically better, 1.2 plus or minus 0.2 grams per cubic centimeter. And notice in both cases my level of precision, this is out to the hundredths, this is out to the hundredths, this is to the tenths, that's to the tenths. So you want to be consistent there. All right, moving on. F. The volume of the jelly bean is given by this equation, so we're treating that as a sphere. Using information, what is the percent uncertainty in the measurement of the jelly bean's radius? So in part D, what we were told is the percent uncertainty in volume is 6%. So if I'm looking at this equation right here, I can say that my percent uncertainty in volume is equal to 3 times my percent uncertainty in the radius. delta R, right? Because of this cubed, I would say delta V over V equals 3 delta R over R. We had a homework problem just like that. So in terms of percents, it looks like this. So if we know that percent delta V is 6% equals 3% times delta R, then delta R would be 2%. So 2% multiplied 3 times over gives you that 6% in volume. Then I said there would be considerable systematic error in the calculation. Systematic means you're consistently doing the wrong thing. Not in this case because of the instrument. You have no evidence in this problem that there's something wrong with the instrument. Some of you said there was a scaling error or a calibration error. And so I gave you a half point for that because at least that goes along with systematic error. But the problem here is we use this equation, which is good for a sphere. And a jelly bean is not a sphere. So we're consistently miscalculating the volume, therefore consistently getting the density incorrect. All right, last problems. Okay, unfortunately, this was a 3-point problem. Many of you lost 2 or 1/2 points because you didn't explain how you knew it. You said that R was the most accurate. That's true. But why? What did you see that told you it was the most accurate? You need to explain that. So it's the most accurate because, I'm sorry, not R, but the B is the most accurate because its center, its peak, or its centers on R, okay? So if I look at B, it's really the peak is close to that. This one is okay, but not as good, and these aren't even, well, they're not very close. And then you say it's the most precise, and you got to explain how you know it's the most precise. Right? That's key to many of these questions is not what's the right answer, but how do you justify that answer? And the most precise because it's the narrowest. It has the least spread. Okay, so that's what we're looking for in that one to get the full 3 points. Last problem we did generally very well with. Okay, each one was 1 plus a half. So the 3 things she forgot units. The delta M should be rounded, right? Instead of 0.0128, you really should call that 0.01. And then lastly, there's a mismatch in precision between delta M and M. Precision. In other words, this is out to the 10th place. This is out to the 10,000th place, 10,000th place. You can't do that. Okay, if you didn't do as well as you wanted to, there's a quiz retake. The quiz retake is going to be very similar to this, just things have been changed around a little bit. So make sure you understand the mistakes you made so that when you do the retake, you can do a much better job and be more confident. As always, ask me any questions if you're still unsure before you do the quiz retake.